Thank you, everybody, for being here. Thanks, Celeste, for introducing me. It's a pleasure being here as presenting part of my Ph.D. thesis, and also as I prepare to defend my thesis soon. So today I will talk about the retrofitting of deficient RC columns using the FRCM system. And I'm sure you all become familiar with the FRCM system as been presented by Dr. Meyer and Dr. Carloni. So today I'll talk briefly introduction, then I'll dig into the experimental programs, moving to the results, and then coming up with the conclusions. So the problem that we're trying to tackle here is that in the old concrete structures that were designed as per old design codes, they have deficiency in the seismic in their seismic performance, as therefore this represent a vulnerability to failure and would lead to a catastrophic event. And if you all witnessed some major earthquake events, one of the most famous one is the 1971, the San Fernando earthquake. And as a solution for this, the seismic retrofitting coming, one example is the column jacketing. And this is what we are trying to do in this research. We're going to use the FRCM jacketing to retrofit the columns. Now, I wanted to explain what's the FRCM, but apparently it was made clear in the previous presentations. I will just touch on the key advantages of this system is that it is compatible with the base material, especially when talking about concrete. And then also because of this compatibility, the crack is visible on the concrete surface, unlike other retrofitting or strengthening systems. Also, the ultraviolet degradation resistance is another key advantage. Now, because this is considered as a relatively new material, there's still some knowledge gap on using this material, on the application of this material, especially when talking about reinforced concrete column and the retrofitting. So the objective of this research is to experimentally explore the use of FRCM system to retrofit deficient concrete columns. Starting with the experimental program. So the experimental program had a large physical reinforced concrete specimen. We had, I'm presenting here 3 of them. We had the control column, unretrofitted. Then C1 is just one representing one FRCM layer. And then C2 is for double layer FRCM. This is a schematic drawing for the physical specimen. It was around 2 meter height. We had the lateral load because we want to test it under kind of seismic loading. The lateral load was applied using an actuator. The axial load was applied using a post-tensioning rod that's passing through the column. The cross-section was 300 millimeter diameter, which is 12 inch in US units. The compressive strength for the concrete was 40 MPa. The longitudinal reinforcement ratio was 1.1%. We used 10M rebars. That's a Canadian size. It's equivalent to number 3 US size. The deficiency in these columns are the lateral reinforcement. The provided lateral reinforcement was 6 millimeter smooth bars, and they were spaced at a 200 millimeter spacing. That provided a low reinforcement ratio of 0.23%. Given that the specimen was designed to fail in the flexure, we're testing the flexure performance of these specimens. So the bottom part of the column is where the plastic hinge will be developed, and this is where the FRCM was applied. This is a photo for the test setup. We had the column supported by a footing anchored to a strong floor. The actuator was applying the lateral load. Push and pull cycles were applied. Moving to the results and talking about the crack pattern and the failure mode. Since the the behavior is kind of a flexure behavior. So we had horizontal cracks started at the beginning. Looking at the control specimen here to the left, the cracks started horizontal. Then we had spalling. After further deformation and cycles of loading, we started having a concrete crushing and also rebar buckling. Similar observation in a way of the crack pattern happened to those retrofitted columns. But the FRCM system was there, so there's something that was happening inside the column. The concrete was crushing, but the system was still confined. As if once we had the rupture in the FRCM and the FRCM system failed, we saw that the concrete came out was fine concrete, as if it was grinded due to cycle of loading and unloading. Also, we had buckling as well. So we had all the same symptoms of failure, but it was kind of delayed. Now, what if we use two FRCM layers, and this is represented by specimen C2? We saw that we had a localized damage in the outer FRCM layer. We did not see a damage in the inner layer, and the inner layer was still intact, and that the beam, or the column had reached when we were testing the column, the capacity of the actuator, the displacement capacity was reached. So we reached the capacity of the actuator, but the column did not really fail in a buckling, or the entire system did not fail. Here, this is the hysteresis curve. The black curve is showing the control. The blue is the one with one layer, and the red is the one layer, and the blue is the double layer. We can see that we had increased initial stiffness. We see we had a peak load for all of them, and then constant or a load degradation happening until we had an event where we had a rebar buckling. As you could see here, this is the control specimen. We had a rebar buckling, and this is a drop in the load. We had similar observation for column with one FRCM layer, but the column with two FRCM layer, we did not see any drop in the load. If we compare the strength added due to the application of the FRCM with the control one, we can see here on the graph to the left that we had a gain in the lateral load capacity between 30 to 38%, depending on the number of layers. Of course, the higher layer provided higher strength gain. If we talk about the ductility, we had an increase between 10 to 20% ductility increase. Moving on the energy dissipation, this graph here shows the average energy dissipation per cycle or per drift level. This is to the right here shows the cumulative energy dissipation. The bars here are the comparison in relevance to the control. We would see that we had increased energy dissipation between 10 to maybe around 30%. And of course, the more FRCM layer provided more energy dissipation. Here, this figure showed the normalized stiffness. We're trying to see the stiffness degradation here. Of course, the FRCM layer provided extra stiffness. It was higher, but if you take the initial stiffness and divide it by the all stiffness reading, we normalize it. You can see that all of them here starts at 1 and then drops afterwards. You could see that this system, the FRCM system, did not really affect the degradation of the trend and the degradation of the stiffness. This is an extra study has been done. I'm just presenting a couple of slides on this, the fragility assessment. We have developed the fragility curves, and then for the control column, you can see that it is fragile. It reached the extreme damage state at just around 0.4 PGA, peak ground acceleration. Adding one layer pushed this curve further to the higher intensity levels of an earthquake. And also, if you could notice, the margin between those curves has been increased. If we compare this to a system or a column with 2 FRCM layers, we could see that we had even further enhancements. That brings me to the conclusion. We can conclude that we had good enhancement in the load capacity and ductility as well. The second layer of FRCM has marginally increased the load and ductility. Energy dissipation was enhanced by delaying or preventing rebar buckling. We did not see a significant contribution or almost no contribution for stiffness degradation. Therefore, we can conclude that FRCM system could be considered as an effective solution for retrofitting seismically deficient concrete columns. At the end, I would like to thank my university, my supervisor, Dr. Ahmed Ritil, the help from the lab technicians, the undergraduate research assistant, Simpson Strong Tie for the donation of the material, and the NSERC for funding. Feel free to connect with me if the time does not permit for questions.
We do have a few minutes.
Oh, excellent.
And I welcome any questions to the panel at this time.
Thank you.